analog to digital and digital to analog converter is in fact a large topic, okay? And if you are doing a course on pure electronics, probably you are going to learn a lot more. Okay? But since we are doing a course on MSc physics, and this is just a paper, and ADC and DAC are only a topic in one of the units, so we are not going into that much detail because it's usually a huge topic. Okay? So analog to digital, okay, and digital to analog. So what happens usually is that this is something which is usually used in our day-to-day life, okay, and this is something which we are going to explain in short, okay. And DAC, let's try to understand this, okay. So whenever you are having any kind of signal, okay, electronic signal, you can actually have an analog signal as well as a digital signal, okay. So when we talk about analog to digital converter, we first need to have an analog signal, okay. So if you are having any kind of wave signals, okay, basically in this form a sine wave and all, okay, these are all nothing but taken as analog signal. So this is an analog signal, okay, and then I need to actually convert this signal, okay, and maybe into a readable form, maybe a system which can actually read it in the form of some electrical signals, okay. So I'll basically have an input as an analog signal, okay, and the output will be in the form of a digital signal, okay. So whenever we are basically having an output, we can basically have it in the form of this form, right? Because when we talk about something like digital signal, it is either 0 or 1, or in general we also call it as high or low. So at this particular point it is 0, okay, at this particular point it is 1. So it is either high, low, 0, 1, on, off, whichever way you want to say, okay. These are basically nothing but called as digital signal, okay. So this is what is this ADC is doing here in general, okay. And we want to do a digital signal to an analog signal, okay, it's the other way. So we can actually have a digital signal, and we can actually give it across different inputs, okay. So maybe this is your input, okay, just drawing it roughly, and then we can actually have an output here, okay. And this particular signal on the other end will actually get an analog form. So this is the basic idea of analog to digital signal, okay. Now if you just want to take some examples, let's say, okay, now you may be streaming some music, okay, you may be streaming some music, so using some app you are streaming a music, but then that needs to be heard in the speaker or your headphones, okay. So that needs to be converted, okay. So this streaming music is more or less digital, so it is transferred to your system, to your mobile phone, to your laptop in the digital form, okay. And then what we actually have got a digital to analog converter. So digital to analog converter, and that is actually nothing but your mobile phone. So your mobile phone has got the specification, has got the electronics to convert this digital signal to analog signal. So your mobile phone will act as a digital to analog converter, okay. And then finally you are going to get the output via the speaker, okay. It might be the speaker of your phone and so on, okay. This is nothing but the analog signal that you are going to get. So this is an analog signal. So this is what is happening. So this analog to digital converter and digital to analog converter is something which is used in our day-to-day life, okay. I'm not writing down the other part, but this is also quite simple. You have your mobile phone and you are speaking on your phone. That is basically you are giving an instruction of an analog signal, okay, and then your mobile phone again converts it, okay, and sends a digital signal to the mobile tower, because the towers would usually read your signals, okay, and then there it is converted, then it is sent to the other end, okay, where the other person will actually hear your voice, okay. So this is what is the basic idea of analog and digital signal. Okay, now the question is why we actually need it. Okay, why exactly we do need analog to digital or a digital to analog converter. Okay, so that's the next point to understand. Okay, why. Okay. So we might have a lot of parameters in our day-to-day life that we actually need to read, okay, or need to understand it in terms of something which we can measure, pressure, okay, temperature, pressure. So you say that okay, the temperature is high, but how much high? How do you measure it? There is too much pressure in the chamber. Okay, what is the pressure that you need to measure? Okay, so that these things are important. If we talk about sound, what is the intensity of sound that we're talking about? If we're talking about velocity or speed, how much is the speed? How much is the velocity? And so on. Okay, so these kind of whatever signals we basically have. Okay, we are basically going to use. These are all analog in nature. These are all analog in nature, right? How do we convert them? We basically use something which we call as transducer. In the example that I have given, this mobile phone is basically nothing but acting as a transducer, okay? And once you get a transducer, you can actually convert this temperature, pressure, sound, velocity, everything into an electrical signal. Convert it into an electrical signal. Okay. Now try to understand this. Temperature. If you are using a digital thermometer, okay, let's forget about the mercury thermometer. The thermometer which are used nowadays more prevalent, okay, measuring a temperature by using IR. So that is a digital thermometer, right? That thermometer needs to have some kind of transducer so that it can actually convert it to that value of 35 Fahrenheit or 90, 96, 97, 98 centigrade. Okay, so similarly for pressure, sound, and velocity also. In your car, if you are having a digital meter, okay, so the speedometer is digital in nature. It's not analog. If it's digital, you know that basically it will actually display a value 40 kilometers, 50 kilometers, and that is nothing but the transducer which is connected, which converts this analog to the electrical signal. So these things are actually used in our day-to-day life and is important. Okay, so what is the basic advantage of converting analog signal into a digital signal? Okay, so let's just try to look into this. Okay, so let's just first look into some of the drawbacks of analog signal. Okay, some of the drawbacks of analog signal. Okay, so easier to understand is analog signal. Digital world is now, previously it was all analog, and then because of which there were a lot of reception issues. Okay, so this is susceptible to noise. Okay. So that means there will be a lot of noise. In other words, we can say that the signal is not going to be very clear. Okay, when we're actually just reading analog signal. Okay, and it is difficult to process. Okay, analog domain. So if you want to understand what are the information that it has, sometimes it becomes a bit difficult. Okay, there are more devices that are needed to actually process. Okay, which was actually used in the old ages when the digital world was not that much prominent. For example, microprocessors, your computer chipset, and all those stuffs. All things they are working basically on digital signals. Previously, those things were not there. We used to use large bulbs. The first computer was in the form of the size of a football field in 1960s, as all of you have already heard. These are all nothing but using digital or analog signals. Okay, so you need large devices to process the signal, to understand the signal, and so on. But nowadays, those days are gone. So obviously, we are moving towards a better technological dependence. Okay, so it's difficult to store. Okay, in analog domain. So storing information in the analog domain is also very difficult. That's why if it was analog, probably we would not be having those hard disk storing so much of data, your movies, your music, okay, data, your files and all. Okay. So this is something which is being tackled by digital signal. Okay. So Digital signal is nothing but okay, I'll just copy this because it's the same thing that I'm going to write, but in the sense of completeness. Okay, so it is not susceptible to noise. Okay, and this is just the opposite. Okay, so if you are asked about the difference between analog and digital signal, or what are the advantages of analog signal over or digital signal over analog signal, you can easily write down these 3 points. Okay? So this is why we actually try to understand what is analog signal and what is digital signal. Okay, but you know there is this law of nature that whenever there is some kind of conversion, having a lossless conversion is very difficult. Okay, so I just like to put this one point here, which is important. Don't think that every digital signal will be completely converted into an analog signal, or an analog signal will be converted into digital signal totally. Okay, there are always possibilities that there will be some losses. Okay, so these conversions from one to the other or the other way are not lossless. There is always some loss of energy in the conversion process, and this is what we call as resolution, right? How much you can convert, that is actually nothing but which is actually can be termed as resolution. Okay, so when we're talking about analog signal, okay, so in general, maybe I can write down this one analog signal, okay, are basically continuous in time and amplitude. Okay, but digital signal is not continuous. Okay, 0 and 1. Okay, there is always a jump. Okay, so we understand this. Analog signal is continuous in time and amplitude. Time and so you have got a continuous value. Okay, in analog signal. But what about the conversions? Okay, so what we are going to look into now is the steps. Okay, for conversion from analog to there are basically 3 steps for converting from analog to digital signal. First is the sampling. Okay, so you basically divide the analog signal into different sections and we can call them as sampling part. Okay, second is something which we call as quantization. So this is all about quantum mechanics. You have to divide it and then you basically quantize it, okay, into certain regions, and then encoding. Then we encode it, okay. And we of course on the other side we have got the decoding for converting the digital signal back to the analog signal. Okay, so what happens usually? Okay, so this is a very rough idea. Okay, what happens usually in sampling is you might be having this sine wave, and this is your analog signal. Okay, and then you basically are going to divide it. Okay, you're going to do the samples here, and then you are going to do this, and this is what is called sampling. Okay, okay, so this is nothing but the first step of digitization. Okay, digital signal. Okay, and then this is quantization. So quantization means, okay, this space here. So you have your signals now. Okay, you have your signals now. You need to probably divide it. Okay, divide it into different regions. So this is done in this way. So there is an 8-bit encoder, 6-bit encoder. Okay, these signals are divided, okay, in these parts. Okay, quantization. So within this bit, this much information will be there. Within this bit, this much information will be there, and so on. Okay, so this is a very typical digital electronic section. Okay, and this is basically nothing but encoded. So encoded in the binary format. So these information are stored in the form of zeros and ones. Okay, and then finally if you want to again convert it back, you have to just do the decoding. Okay, so this is what is done here. Okay, but then quantization is a big term, so let me just write down the definition of quantization. Okay, so exactly what do I mean by quantization here? So you already understand what is quantization. Okay, but then in this aspect, okay, in this term, it is the process of assigning a sample. So sample means we are actually having the analog signal being divided into different parts. So that is the sample that we have. That is the analog signal in general. Sample signal value from discrete set of values. Okay. So you've got a number of values, okay, and then analog is more or less continuous, but quantization we're talking about, that means we're talking about the discrete values, okay. Some values will be missed out. So if some values are missed out, we need to understand the term which is basically called as resolution, okay. So resolution has to do something with number of bits. More the number of bits, more will be the information that actually can be stored. So in general, if I say number of bits, it's in which the quantized signal is going to get. So it's not as simple as I've written it, okay. This is just for the purpose of the basic understanding of analog to digital conversion, but this is a very important part of digital electronics, you can say, okay, or when we're talking about the conversions of analog to digital signal in any kind of chipset form or microprocessors and so on, okay. So in general, if you want to just understand it in a simpler language, okay, what does resolution exactly mean? So resolution, okay, defines the minimum change in the input signal, okay, which can be detected by the ADC, by the analog to digital converter. So this is the minimum change. So sometimes it does happen that if the change is very less, okay, in the input signal, this may not be recorded in the digital form, okay. So this is how much change it can actually record. Based on this, we're basically having something which we call as the resolution, okay. So let me just give you a brief on this, okay. I've got some examples, probably that will help us to understand this a bit better, okay. Try to take this up. So let me write down an example. Okay. So we have, if for a given ADC, okay, given analog to digital converter, let's say I have the resolution, okay, resolution as n bits. Let's say the resolution is n bits, okay. So what happens is, then in binary number, okay, binary number system, the total number of discrete levels, okay, which can be defined, okay, the total number which can be defined is 2 to the power n, okay. So if we are having an n bit system, that means that it's a 2-bit system, and that means the number of levels that we can actually have to store the data will be actually 2 to the power n, okay. 2 square, maybe if I have 2, but I'm not taking 2, I'm just taking n. So maybe I should write down n here. 2 to the power n, okay. This n is this n that we're talking about, 2 to the power n, okay. So this is there. So the input signal will usually get quantized in these 2 to the power n levels, okay. So the input signal, okay, will get quantized, quantized to 2 to the power n levels, okay, to 2 to the power n levels, okay. So in general, if we are basically having, let's say, okay, before I take this example, so if we are basically considering, let's say it's a 3-bit system, okay, It's a 3-bit system. So n is 3 here. So that means we'll be basically having, in this particular quantization that I'm talking about here, we'll be having 8 levels, right? So that means which will be equal to 2 to the power 3. Okay, so this is nothing but 8 levels. Okay, so then can we actually write down what is resolution right now? Okay, and then try to understand it better. Let's try to do this. Okay, so then if I just want to write down what is resolution, that means how much change in the input signal can be read. Okay, so full scale range, that means let's say V max minus V minimum, within which the signal is there, the analog signal, V max divided by V minimum. So that means we can say between this and this, okay, between these 2 points, okay, divided by 2 to the power number of bits. This is the definition of resolution if you just want to write down a mathematical relation for this. Okay, so if we basically consider for a 3-bit system, for a 3-bit ADC, okay, let's say it's a 3-bit ADC, okay, and let's say the full scale range, full scale is equal to 10 volt. By full scale 10 volt, I mean it's this V max minus V minimum. Okay, so what we can do is we can actually find out the resolution here. Okay, so if we want to do the calculation, this is nothing but 10 divided by 2 to the power 3. So it is nothing but, if you do the calculation, it would be 1.25 volts. Okay, so what does it mean? That if there is any change uh, lesser than 1.25 volts, okay, you know this is always fluctuating. If there is any change lesser than 1.25 volt, your ADC cannot measure it. Okay, and this is what is resolution is all about. Okay, so I thought of just putting this sentence. Okay, I think this is important, so let me just probably write down this. Okay, that is the minimum change in the input which can be detected by ADC, okay, is equal to 1.25 volts. Okay, so this is the minimum that the ADC can actually detect. This is the resolution. So imagine you are actually having the voltage along this direction, right, and it is changing. If it changes by, let's say, 2 volt, it can be detected by the ADC, but if it is less than that, or even might be 1.25 volt and less than that, it cannot be detected. Okay, so how can we increase the resolution? Okay, that might be another question. Okay, and then adjust it here. Okay, so we can increase by increasing the number of bits, right? So if we increase the bits by increasing the the number of bits, okay, we can increase the resolution. So this is what is an analog to digital and digital to analog converter is all about. Okay, so we are not going to go further, as I said, and you can understand also this is actually a huge topic. Okay, but we are just going to cover up to this particular point. So a possible question might be to explain resolution. Okay, might be a numerical problem which is actually similar to this. Okay, you can do that. These kind of questions may be there, and then you have to just explain what is analog to digital and digital to analog converter. Okay.